Cool. I'll start in 5 minutes, and here's some waiting music.
Thank you.
I get deeper into this thing. The deeper I go, the more knowledge I know, what to sing, what to bring. What I get.
Cool. I think we have people. Can everyone hear me and see my screen?
Yes.
Okay.
Yes.
Well, everyone, thank you for joining in this session, and we'll be talking about optimizing Unity 3D. Just a bit about me. I've fiddled quite a bit around with Unity 3D now, and these are some of my works. What I tend to do is I used to throw in a lot of external packages, and that too in VR. I do lots of immersive, audio reactive stuff, and there you need your FPS, frames per second, to be very high, especially in stuff like VR, which you need to you need to at least consider at least 60 FPS per second. So it started with this particular experiment. As you can see, it has a very high-end mesh, like a very heavy mesh, and it has like hundreds and thousands of stuff. And this was in VR. So when you talk VR, you instantly go from 1 to like twice the rendering performance you need. Lots of audio reactivity stuff as well. So there also you need lots of real-time compensation. And this was also a web VR experience, which means it's hosted directly on browser. You can actually check it out at meraki.embracingearth.space. So because it was a web-based, browser-based VR experience, this needed lots of optimization. And that's when my journey started in optimizing Unity. And now these are just some of the tips and tricks and tools which I have developed, and I just keep them in mind in back of my head when I'm developing something, and I just keep implementing them as I develop. So just some general terms in Unity, which we need to look at when we are talking about optimization. We have our statistics window in Unity, and frames per second, pretty basic, frames per second. Then we have draw calls. Draw calls is actually the number of calls your CPU, GPU makes for a frame, ask for a frame to render something. So they can be like, hey frame, clear everything. Hey frame, draw this line. Then hey frame, color this line. So each frame can have hundreds and thousands of draw calls. Set pass calls is referred to as number of shader passes your renderer needs to do. And trees and words refer to triangles and vertices being rendered in your scene. Basically, what we need to look at is we need FPS to be high, draw calls to be low, set pass calls to be low, trees and words to be low. Okay. My internet is also a bit laggy, so if I cut out and like come back, just tell me if I missed something, and also if you want me to stop and elaborate on something, just ping me in the middle. Cool. You guys with me?
Yeah.
Awesome. Thanks.
Yeah.
So let's jump to Unity now, and New scene. So this is where you can get the stats window. This is the game window. And when I started, I was not at all in like habit of having the stats window, but now as I do stuff, and as I said, I tend to throw lots of packages, SDKs, AI, audio reactivity, all these kinds of stuff. So I always have the stats window most of the times open, and I'll just keep having a look at FPS and all these things over here. So as you can see, we talked about FPS, then we have batches over here, we have trees and words, and yeah, so you need this to be high and everything here to be low. In Unity itself offers a lots of tools, and we will be going into two tools which gets most of the job done. We have Unity Profiler, one of the main tools. You can get this sweet bird in Windows, Analysis, and Profiler. So Profiler shows you whatever thing or whatever component within Unity is optimizing using how much of your power. So if we run the game and you have your profiler on, you can actually see what's taking most of your performance. So if you're unable to decrypt what is taking performance, it can be scripts, it can be rendering, it can be UI, it can be physics. You can come into profiler and check it out and just go from there. We have second analysis tool, which is frame debugger. So frame debugger, it shows us every draw call which is happening in Unity, and you can see the draw calls over here. So it says color, and you can also see the preview as you select. You can scroll through it and you can see how your scene is being rendered in one frame. This is one frame. It says clear first, then clear the Z depth axis, then it says draw mesh. So that's basically our skybox over there, and not much stuff right now. So batching is one of the main terms when we talk about optimizing in Unity. Batching refers to combining draw calls. So what you can ask Unity when it's rendering stuff is that, hey, Unity, you are having lots of draw calls. Can you combine it in one single draw call, and can you just throw it out? We'll go into tips and tricks on how to do that. So one of the very first things you can help Unity in optimizing internally is you can set things to static. Static refers to whatever thing is not moving in your scene. So if you have a box if you have a full room and you set it to static, note that you won't be able to move it, or if your scripts are moving it in runtime, it won't be able to move. So set static to only objects which are static. Combining meshes. So the best way to combine meshes is do it in your 3D program. It can be Cinema 4D or Maya or anything, literally. But if you need like more control inside Unity and you're working on different things and you want to combine meshes inside Unity, but you still want the freedom to move them around inside Unity as well, what you can do is you can use this one of the scripts. I'll just put it out there. I use it often. Sorry about that. So what this script does is you put it in a game object and you put inside it whatever the game objects you want to combine, and you throw it on a game object. And let's have a look at our batches here. So batches is number of processes your renderer needs to do in making one frame. So you see, it has combined all of them, it has disabled them, and it has thrown it inside a mesh, and then it has rendered it again. It's pink because we also need to give it a material. So if we give a material to the main hierarchy, it combines everything inside the hierarchy and drops it inside one mesh. Well, if your things are having different materials, this method is not for that. Another great software is Mesh Lab, which helps you optimize stuff. Say you have downloaded something from online, or you are a modeler. Like I tend to model a lot, but I'm not very optimized professional modeler, so I just model with very chaotic way. So Mesh Lab, you can go and it's a software. You can throw in your model and you can choose, okay, optimize it 10%, and it will optimize it. You can choose between 10, 90, 100, and it will affect or optimize it accordingly. It's pretty good, and it doesn't like create or deform your 3D structure depending on your how much you optimize it a lot. GPU instancing, it's one of the most important methods, I think, which comes into optimization. And let's say I have thousands of game objects and they are all using same material. Now, a common thing here can be walls, trees, mountains, anything literally. And let's say they all are using same material. So if we have a look at our batches over here, we have 135 batches. And let's also open our frame debugger. Yeah, here. There. So it's calling each frame and it's drawing each cube individually right now. Now what we can ask Unity is, hey Unity, you're calling all these meshes one by one and they're all using the same material. Can you just call all these material in a single mesh, in a single draw call, and can you just throw it once? And it's as easy as going into your material settings and enabling this option, enable GPU instancing. And you can see here instantly, it says saved by batching. We have 128 batches saved and it drops to just 7 draw calls. And you can also see it here. Culling. Culling refers to disabling the unseen objects inside Unity. So let's take this script out for now. And we're gonna just separate them. So there are two types of culling in Unity. There's frustum culling and occlusion culling. Frustum culling is enabled by default inside Unity. It happens every time. So frustum refers to frustum of a cone. So this is our frustum of a camera. And if we keep an eye out on our batches, as you move forward, what is it? GPU instanced. Yeah. So say you cannot do GPU instancing, and as you move forward or as you move around things, the things which are not inside the frustum, it gets disabled by default. Now you don't need to do anything to implement this, it just happens. We have another kind of culling called occlusion culling. Occlusion culling refers to you do not render anything which is occluded, which is not seen by camera. So say we have a wall inside, we are in a room and we have a wall, but you can see here we have 136 patches, right? So Unity is rendering all these cubes, but we are not really seeing it in the game window. So we can disable that. And to do that, we go to occlusion. You can have this window open from Windows, rendering occlusion. And for occlusion, only happens on static things. So you set everything to static, which is they are not moving in the scene. You go to occlusion, you select it, and you click bake. There. Oh, that's weird. Classic Unity, give me a second. Well, I'll come back to that. Or maybe not. Well, I need to dive in this. I probably did something in this Unity project file and it's not working. But the concept is you select everything and you set it to static. You come and you bake the occlusion. And if you have a wall or anything, it won't render everything which is outside the wall. Let's try it last time. Oh. Anyway, I'm gonna move forward, but I probably need a new Unity project file. But you come to occlusion, you set everything to static, and you bake it. And whatever is not seen in the scene, it won't be rendered. Another thing you can do is you can go to camera clip plane and you can decrease that. So say if you are in a huge field, so whatever will be inside this frustum, it won't it won't occur it. So if you have something over here in a huge field and you apply, say, fog in it, but it's still in the frustum culling, but there's no wall, but there's fog. So what you can do is you can reduce this camera clip plane, which means how far it can see. Another thing you can do is you go to frame debugger and you see what's actually happening. And you can see things here like render shadow, and say I don't want shadow and I'm working in 2D, or I'm working with some kind of graphics I don't want shadows in. So I can go to my quality settings, which is in project settings, graphics. and we can disable shadows and reflections or anything over here. If you want, and if you are having a bit of troubles with optimization, you can also set these things to low and medium, but this is least recommended, but it's one of the options which exists there. Skybox literally takes a lot of power, especially in VR, and this is a common mistake. People don't disable skybox if they are inside a room or if the skybox is just not seen. So you can go into lighting and you can disable skybox. Bake lighting. So let's throw in a point light over here. So bake lighting refers to whatever you bake the light. So right now the light is running in real time. That means it's processing in real time. You can go into light settings, you can set it to bake, then you go into rendering, light settings, and always disable auto generate because it just generates bake lighting if you have any bake lights every time you make any changes inside Unity. You also want to use GPU progressive method in Light Mapper if you have a huge scene, because well, GPU is way faster than CPU, and you click on generate lighting. So let's have a look at our batches over here. We have 55 batches. We have a light. We have set it to baked instead of real time, and we bake. You need to save the scene before baking lights. Save scene. When you bake light, it also considers the bounces and reflections, so it makes your things look more natural, and we can see as like our batches are reduced. So when you bake light, you can also disable light, and you can see it's there because now it's baked in the texture, and you can actually see it here in scenes and baked light map. So this is our baked light map. It's there. One thing to note, if you have like moving things inside Unity or your scene after your lighting is baked, it won't have like proper lighting. So if you want real-time lighting in your players, you can use a mixture of baked and real-time lightings. When you're using VR, XR is, or mixed reality, multi-pass and single pass is one of the important things you want to look at. So what's happening in VR is, because we have two screens to render, by default Unity is in multi-pass method. So it's calling each left and right eye, and it's rendering each left and right eye in separately. When we set it to multi-pass, we ask Unity that, hey, instead of rendering separately, we increase the width of our canvas and we render it in a single pass. And we display the left eye part to the left eye and right eye part to the right eye. So that makes sense. Let me draw it here. So we have a left eye and we have a right eye. We are rendering one by one in multi-pass. In single pass, it's as easy as we ask Unity to double the width of canvas, and we throw like each draw call in a single pass instead of 1 and 2, and we divide it into like left eye and right eye. To do that, it's as easy as you go to build settings, you go to player settings, and XR settings, say we have virtual reality on. Let's give it a sec here. And we set from multi-pass to single pass, as easy as that, and it just reduces or halves your rendering performance you need inside rendering a VR scene. While we are in here, we can also give me a sec. Yeah, so we can also change gamma versus linear. It's not really an optimizing trick, but it's more like a visual trick. So by default, Unity is in linear method, which Unity is in gamma method, which is it's very washed out. And when you switch to linear, you can have more bounces in lighting, and it instantly makes your scene looks good. If you have optimized quite a bit and you want like better lighting, you can just come here, player settings, other settings, and you can switch it to linear. And you will instantly see your scene looks more natural and more beautiful, especially if it's an outside. It has terrain, it has trees, and stuff like that. If your game is still slow at this point, there are things which I am not covering, but it's there. But first of all, try making a build. So often when I'm playing inside VR or XR, I'll be at 40 FPS at the end of my project, and I used to think, oh shit, it's not 60. Like I can't make it work, and I have done everything I know so far inside Unity to optimize it. But Unity editor itself, it takes a lot of performance and power. And once you build the game, your frame rate will be better. LOD optimization, I haven't covered this because there are hundreds of tutorials and it needs a bit of pre-production at your end. LOD refers to level of detail, and the basic concept or the idea is you have different meshes for the same model. So you'll have a mesh which is less detailed, and you will have mesh which is medium detailed, you'll have mesh which is highly detailed, and you can even include more. And the idea is the farther you are from the game object, the less detailed mesh you render, because you can't see details at far. And it's not worth rendering a 30K or 60K mesh when you are far from something. Fix inefficient code. This is something which just comes while coding, and it comes with years of experience. You don't want to have unnecessary for loops or, yeah. Disable unused scripts and game objects when not in use. I used to do this a lot where I'll have lots of scripts, but I'm not using them till my player is in third stage of the game. But you need to understand that each of these scripts are having that update function run each frame. And if you have for loops and lots of weird stuff happening inside the script, though you're still not using it, it's still updating. So you can have an external script which just disables all those scripts and game objects if they are not in view, if they're not in scene, or if your player is just not at that stage where you need to use that script. Check out ray marching. Ray marching is something fascinating. It's still new inside Unity, but there are tools like Ray Marching Toolkit. If you Google it, you'll find it, and there are lots of GitHubs by indie developers. Ray marching refers to rendering without meshes. So if we see here, we have component as like a mesh renderer, and then we ask Unity to put a skin on it. But ray marching happens directly over a GPU and with maths. So there's no mesh inside. And my night is acting weird. Can you guys hear me? Are you guys with me?
Yes.
Yep.
Awesome, thank you. So check out ray marching if it's a bit pro level, and you need to have a bit of maybe shader coding experience. But well, these are some of the things I did in remarching, and I am not a shader coder as of this moment at all. So there are lots of toolkits like remarching toolkit, and which helps you do remarching stuff easily inside the editor by dragging and dropping stuff. There are a few gits which, if you know a bit of coding, you can go in and you can try like uh, good things, and things like performance heavy things like metaballing stuff which can't be done in real time. If we try to do this, like combine two things with a mesh in real time, it's a mess. You can't do it for more than like 5 or 6 objects at max. So ray matching is really handy there. You can create infinite rooms, infinite fractals, and there's also another shader component you might want to look at is compute shaders, um, which really comes in handy in baking stuff and putting it inside VFX graph and stuff like that. Okay, sweet. I ran through it pretty fast, but I hope this helped. And if you are dealing with like any kind of optimization trick or any kind of optimization problem, just apply any of these tricks, and I assure you by the end of all these, if you have done most of these properly, you should be good with your optimization. Well, if you have any questions or if you would like me to go back to any of the things, just ping me now. Oh, sweet.
Hi, Sahaj.
Hi,
I just wanted to ask something regarding gamma and linear lighting thing.
yeah.
You were telling that one of these works better for environments. Which one was that? I couldn't catch the word.
Here, well, so both of them work good, but in linear lighting, it's more the bounce of lighting is considered more, so it gives you a better lighting, and you can see the difference over here. So
Yeah.
gamma, you will have washed out lighting, and linear, you will have a bit better bounces. But you gotta know that gamma uses like 10 to 30% higher performance, while linear uses 10 to 30 higher performance, and gamma, because it's washed out and it's using less color light bounces, it's um, way more optimized.
Yeah.
But I always prefer linear.
Yeah, it's cool. Thank you.
Sweet. Well, I just want to show you guys this occlusion culling, which for some reason, Unity being Unity was not working before. So as you can see over here, I've set all these to static, and we have occluded things. So we have these boxes, but we have a wall in front of us, and it's not getting occluded. And as soon as we come out of that, we can see it's getting rendered. Well, your things need to be in static when you do this, but you can trick Unity to you can move stuff after you bake, and you can do interesting stuff like, enable or showing game objects when a player is closer to the game object. It's not the best way to do it, but like I tend to trick Unity into doing stuff like this. And every time you move anything which is static and you want to include occlusion, you gotta select everything, go to occlusion, and bake it again. So it becomes good. Yeah. Cool.
Hey,
So
Sahaj.
Chris, yeah.
I just want to bring people's attention to the chat. I put up some interesting GitHub things. The first one is a really good tool to optimize meshes where you can draw the mesh flow that you want on the mesh. So you can sculpt freeform like in ZBrush or something, and then you can use this tool to draw the edge flow that you want and to also optimize. So that's pretty cool. And the next one is Imposter Maker, which is the kind of next level down from level of detail where you can get really good representations of objects, but with very tiny vertex count. So that's worth checking out.
Awesome. Thanks, Chris. It'll help me as well a lot.
And also that there's, just in terms of the optimizing there's a really the coding, there's a really simple thing that you can do, which is just to say, for a lot of things don't need to poll update every frame. So you can write a little class, which is like a utility class, to say, well, just poll this particular number, not every frame on update, but every, say, 30 or 40 or 50 or 100 frames. And that's often just something really simple, like I'll just type up something and then put it in the chat if that's okay. It's a great training, Sahaj. Thank you so much. And will you be able to put the PowerPoint or whatever it is that you've used up in the chat?
The slides? Yeah, sure.
Yeah.
Should I just email it to you, or I'll send it in this group.
That should work.
There's a typo.
Yeah, there's a typo.
But yeah, no, I get the logic. So you're creating your own update.
Yes.
Like you're creating your own class, not class that update thing.
Yeah, that's right. It's just going, yeah, update me every 15 frames or whatever number of frames.
Yeah, that's very thoughtful.
Yeah, that's awesome, Sahaj. Thank you.
Cool. Thanks. Well, hope it helped everyone. If you are stuck anytime in Unity, I know a lot of people won't remember stuff, so I'll put this recording as well as this web presentation. You can come here and you can just look at some headlines and you can figure out stuff we did. Static, combining meshes, occlusion culling, clip plane, quality settings, disable skybox, bake your lighting. If we are using XR, switch to multipass to single pass, gamma versus linear, and then LOD optimization, make a build, fix inefficient code, disable unused game objects, and use Chris's code and check out rematching. Thank you everyone for joining, and well, that's outro music. I'll be graduating soon, this semester, so you can follow my work at here, embracingearth.space, or write to me at sz.sahaj@embracingearth.space if you have any queries regarding Unity, and I'll be happy to help you. Thank you.
Thank you, Sahaj.